We're going to be going through the study guide, just giving you some hints and points in the right direction, not explaining every single problem. That's your responsibility. As I go through the study guide, items that are in red especially will be things that you should just memorize. There'll be various equations and concepts that as you're solving, you need to have memorized to do well on the test. Let's start with our reference pages. These first two pages are things that you should have memorized. Going over basic concepts. A sector area is a portion of area. It's a fraction of area. And how do you solve that fraction of area? It's theta over 360, that central angle, times area, which is pi r squared. A circumference length, which is just a piece of the circumference, is a fraction of the circumference. And to get that, it is theta over 360 times d pi. That would be arc length and sector area. In all our volume and surface area equations, when you see a capital B stands for area of the base. Area of the base. So if your base is a rectangle, of course, it's length times width. If it's a right triangle, it's going to be leg times leg over 2. Trapezoid is average the bases times the height. Of course, a circle is pi r squared. A triangle is base times height over 2. Square is just side squared. Any regular polygon with all equal sides is perimeter times apothem over 2. Circumference, of course, is d pi. The sum of interior angles, sides minus 2 times 180. The sum of exterior angles will always be 360. That each interior is sum over sides. Sum being this. And sum of exterior angles is also sum over sides. But in this case, the sum is 360. When we have solids which are similar, here, for example, the ratio of the sides, the edge to edge, we're going to call it x to y. But the ratio of the areas is going to be x squared, y squared. And the ratio of the volumes, if you were to do the volume for both of these, is going to be x cubed, y cubed. So for example, this is a 1:2 ratio, 12 to 24, so that would be your scale factor. Ratio of the areas is going to be 1 squared and then 2 squared, so your ratio of your areas will be 1 to 4. Ratio of the volumes would be 1 cubed and 2 cubed, which would be 8. For lateral area of a prism, you find the perimeter of the base times the height. Surface area is whatever the lateral area is plus the area of two bases. And volume is the area of a base times the height. For a cylinder, instead of pH, it's CH. Otherwise, it's exactly the same thing. That's the only change. This is lateral area plus two bases. And of course, this is base times the height as well, this way. For a pyramid, for the lateral area, you have 1/2 perimeter, and then it's going to be slant height down the outside, PL, 1/2 PL. Surface area is LA plus only one base. And volume is going to be that base times the true height. For a cone, this row is exactly the same as this row, except instead of P, it's C, so it's 1/2 CL, slant height being the outside. And then this is LA plus B. And of course, this is going to be area of the base times the true height. Oh, this is over 3. Both of these are over 3. Area is 2 dimensions, therefore the fraction from a prism to a pyramid is 1/2. Volume is 3 dimensions, so it's divided by 3. For a sphere, surface area is 4 pi r. Volume also starts with 4 pi r. But then to complete, for surface area, it's 4 pi r squared. For volume, it's 4 pi r cubed over 3. Graphing of lines. The first thing you want to do when you graph a line is take a look. We want y equals mx plus b form. You identify your b here first, and that's the y-intercept. And then you take a look at your slope. In this case, it's -2 over 1. So from that intercept, there's your rise, and there is your run. And you count that out and scope your line. For this one, since it's in standard form, you want to get y all by itself. So we're going to do that first by minusing 4x both sides. So we have -3y equals -4x plus 3. We're going to divide by -3. Get y equals +4 over 3x minus 3. Put y equals mx plus b. And now graph your line. Graphing of circle, your equation that you should have memorized is x minus h squared, y minus k squared equals radius squared. H and k will be the center of your circle, and then just the radius, once you solve it, will be the radius. So you graph your center, and then you want to count out your radius, left, right, down, and graph your circle. Here it says graph the points -5, 5, and 3, 4. So -5, 5, and then 3, 4. Says first you want to find the distance between these. So you're going to use the distance equation. Here's your template. You're going to need to solve for that. Always write your template first. And once you solve for that distance, it says write an equation of a line with a center. Now we just identified this right here, -5, 5, as our HK. But passes through the point 3, 4. That means we have a circle here that's going to go through 3, 4. That means this distance that you find is your radius, whatever it is. And then you want to write an equation of a line once you solve that and plunk in your HK and your radius, x minus h squared, y minus k squared equals radius squared. So ultimately, you're going to find the h, the k, and the radius and write an equation of a circle. It says Tom is standing at the top of the cliff waving to his friend. Bob is standing on the beach below. The angle of depression from Tom to Bob is 50 degrees. Bob is standing 40 feet from the base of the cliff. How tall is the cliff? Key words. Tom is standing on top of a cliff, waving to his friend on the beach below. Angle of depression from Tom to Bob is 50 degrees. Bob is standing 40 feet from the base of the hill. And then our question is, how tall is the cliff? The most important phrase here is, what is angle of depression? An angle of elevation starts from a horizontal and goes upwards. An angle of depression starts at a horizontal and goes downwards. So since I have an angle of depression and it's 50 degrees, first thing I'm going to do is draw an angle of depression, which is horizontal, angling downwards, and that's 50. So I start with the angle of depression. Then I read the rest of my storyline. Tom's standing on top of a cliff. So here I have a cliff, and Tom's standing on top of that cliff. He's waving to a friend on the beach below. So here's the beach below, and here's Bob at the beach below. And the angle of depression is 50 degrees. Bob's standing 40 feet from the base of the cliff. How tall is the cliff? There's your unknown. Since you have an angle here and a side length of a right triangle, you're going to be using SOHCAHTOA to solve. It says in the rectangle below, AE is 2x plus 6, CE is 6x minus 14, and the measure of angle BEC is 52. Find everything possible. This one, it's just important to label everything properly. AE is here, and CE is here, and BEC is right there. Now, if you remember, in a rectangle, all four of those pieces are equal, and of course you have right angles. And here, keep in mind that this creates an isosceles triangle in which these point towards congruent angles as well. Label these, solve for x, plug it in, find what you can find, put this angle where it belongs, and find everything that you're also able to find. It says in the diagram to the right, ux is 10, xv is 8. Find all possible segments. Let's see what we have here. Let's put our information. Ux is 10. So u all the way to x is 10. And uv or xv is 8. Find everything possible. Now, what's really, really important is you do not assume that these two segments are equal. They're not, because if you look very carefully, this point is not on the circle, but V is. So do not attempt to make those 4 and 4. What is the only thing you can do? I'd like you to physically trace UV, and physically trace Vx. Physically trace UV, physically trace Vx. Now sing with me. If tangent to a radius, if tangent to a radius, right angle at the edge. Now that you have a right angle, there are things you can solve for. These are the segments that you are expected to find. That you can find, the light blue. That you can find. This you can find. That's what you're expected to find. That's everything possible. For this problem says, a circle graph summarizes 300 members of a university sorority by their majors. The central angle for engineering slide is 43.2 degrees. How many sorority members are engineering majors? What percent of the members are engineering majors? First off, it's really important to spot. Ask yourself, how many question marks are there? And if you look very carefully, there's 2 question marks. And if there's 2 question marks, that means there's 2 questions. The first question says, how many sorority members? So it's how many members is the first question. And the second question is, what percent? Now, you look at what kind of information you're given, and you're given that the engineering wedge is 43.2 degrees. And then you have to ask yourself, it's out of your whole here. If you're dealing with degrees, your whole circle is represented by 360 degrees. For both of these, it's part over whole equals part over whole. You need to determine what your wholes are depending on what you are looking for. In the left, your whole is how many members on the right. And here, it's out of percent. So you're going to be doing this twice. This one says a wheel has a diameter of 20 centimeters. How many revolutions will it take to travel 20 meters? Let's find our key words. A wheel has a diameter, 20 centimeters. How many revolutions will it take to travel 20 meters? Key things, guys, you need to watch out for. Be very careful that you take very close account of units. And if you are dealing with units, you should follow this basic rule of thumb. Convert units before you crunch numbers. Convert before you crunch. Convert before you crunch. That means you should take either centimeters into meters or meters into centimeters, but be consistent either way. And the other hint you're going to get here is this word revolution. When you deal with a revolution, the word revolution, the word turn, are all code for circumference. So just keep in mind that the word revolution and turn are code for circumference. Here it says the measure of arc PTR is 238 degrees. Find PSR. PTR, it's an arc, so we're going to sweep it around this way. It's 238 degrees, and we want to find the measure of PSR, the angle, so we trace it. That is our question mark. First thing you want to do is establish what kind of angle this is here. If you look very closely, it has 2 tangents, so it's a tan-tan angle. So all of those angles you learned earlier, the measure of a central angle to its arc, the same. So central angle equals the arc. The smaller angle of inscribed is half the arc, it's plane. So inscribed angle equals half the arc. That whole list there, this one is the tan-tan angle, and that one is big arc minus little arc over 2. And you have the big arc. I'd like you to physically trace this little arc. Now, if you can't figure out this little arc, the only thing I recommend you do is put your pencil here and just sweep around, all the way around. Put your pencil there again, sweep around again. Keep sweeping it around until your brain registers what you should do and to find this missing arc, which is your smaller arc. It says the area of a circle is 196 pi centimeters squared. If the same circle was a wheel and rolled 20 times, how far would it travel? Remember, the basic rule of thumb is always do what you can do. Area of a circle. So we're going to write area of a circle. Is an equal sign. So it is 196 pi equals pi r squared. So we have a circle here. If the same circle was a wheel and rolled 20 times, so if we're going to roll 20 rolls, it's asking how far are you going to travel. Now the word rolls, you should know, means circumference. So do what you can from here. Always do what you can do and wrap up that problem. It says here, if the measure of one exterior angle of a regular polygon is 36 degrees, what is the name of the polygon? It says, what is the measure of one exterior? Keep in mind, it says, the sum of interior angles, equals sides minus 2 times 180. The sum of exterior angles will always be 360. But this one says I have one and it's exterior. And the word poly means you don't know the n. You don't know what the number of sides are. So you ask yourself, if you knew the number of sides, how could you find the exact angle out of 360? And of course, it is if you knew the number of sides, you would take the number of sides, divide by 360, and that would give you a single exterior angle. Finish it up from there. Here it says in the diagram to the right, find all possible angles. Well, there's a couple key things you want to keep track of. Notice the hatch marks. Notice the right angle. Physically sweep. And you should be able to take it from there. Understanding what these hatch marks entail. Remember, retrace the hatch marks and then follow them to where they point to. That's going to tell you something. Solve for all the angles. Next problem says, find the value of x. Keep in mind to keep your answers in simplified radical form. Well, let's look at what we have here. We have a 90. We have 45 here, which implies there's a 45 here. So we have a 45, 45, 90-degree triangle here. And here, that's 60, that's 90. So you add those up, take it away from 180, and of course you have figured out you have a 30, 60, 90 triangle. You should automatically know these tables. If you don't, you need to memorize them. In a 45, 45, 90, the legs are equal. And the hypo is whatever the leg is, times square root of 2. In a 30, 60, 90, you have the short leg. And then the hypo is whatever the short leg is, times 2. And then the long leg is whatever the short leg is, times root 3. Use that as part of your process to start with what's given, and then work your way towards what you're looking for. It says here in the diagram to the left, draw in a radius to create a right triangle. Find the length of the radius. Then trace all radii in the circle and find the value of x. So it says draw in an additional radius to create a right triangle. Well, let's see what kind of radii you already have. Radii goes from center to edge, center to edge. So right now you only have 2 radii. We want to draw an additional radius so we create a right triangle. So let's look at where our angle is. There's our right angle, and a radius has to go from the center to the edge. So your only spot you could put that would be this way. Center to edge there is a right triangle. Center to edge there is a right triangle. You can take it either way. You're going to be using that right triangle to solve for something, but keep in mind what you're ultimately trying to solve for is that little piece, x.